Thank you, Mr. Kang, for your nice introduction. But during our taking photo, nobody hear about your explanation about me. Anyway, good morning, ladies and gentlemen. When I was asked to give a talk in the plenary session of this oceans, I immediately accepted because it is oceans. And so I thought my topic will be about the ship dynamics or underwater vehicles on which I have been done over the last 40 years. But Dr. Gang here called me, and my topic must be Korean R&D plan. So when I was young, I was more or less involved with this topic, but at my age, I have been away. So, but I have no other choice to accept his proposal because he has a real power. So, so the I assume that most of all are not aware of about this topic. Is it? Except some people in the front line. So I feel safe, and I try to explain about the R&D plan in Korea. So I will follow the topics shown in slide. You brief background for this roadmap 2020. And before we talk about the future, we try to look back what happened over the last 8 years in the name of Marine Technology Plan. Then we come out with the main theme, Roadmap 2020, and lastly, YEOSU. But I may skip it because in the opening speech, the President Kang here mentioned about the reformulation of CODI to YEOSU, and we are 12 minutes behind the schedule. So what I can do, help the organizer, is to short my time. So background. So in Korea, we have a three-layer hierarchy concerning with R&D plan. Top level is naturally national level because we heavily depend on governmental budget. So we have now in the third national science technology plan, which is called 577. 5 means the research money is to be 5% of GDP. And this year, this ratio is 3.7% of our GDP. So it is a world top three after Israel and Finland. So the proportion is very high, but the problem is the money itself is small still. So the mid-level, we had so-called OK, Ocean Korea 21 plan, first phase and second phase. When we provide this plan, at the time we had Ministry of Marine Affairs and Fishery, which is now disappeared and dissolved into two. The main body moved to Ministry for Land Transport and Marine. So I'm sorry. So here. So MLTM stands for Ministry for Land Transport and Marine Affairs. Unfortunately, Marine Affairs is a very small portion of this ministry. So we work out MT plan for the first time in Korea in the year 2004, which has a time span of about 10 years. So next year we'll come to the end of this plan. So we now are in a position to prepare another the R&D plan. So it's called MT Roadmap 2020, which I will briefly explain in my talk. So global megatrend, you know very well. Also, we have the same opinion that this graph accommodates more than 9.1 billion people in 2050, which is too much. So which triggers a lot of problems. For example, limited energy and natural resources. We have to find alternative, perhaps from the ocean. That's why we come here to talk about future technology. And the most body of this present energy is based on the hydrocarbon, which emit a lot of CO2. And due to the greenhouse gas, the globe is warming, and a lot of climate change. We have experienced last winter uh, the the weather change, which have not expected and experienced before. So then we have to keep our environment clean, not only for us, but also for our next generations. So still we need growth, but which must be sustainable to keep it going on. And we try to solve these global problems partly by marine science technology through fusioning existing the disciplines. So based on this mega trend, we have a chance to look at this problem, sharing the same opinion as a global. And we have experienced natural disaster has been intensified over the last 10 years. And we have to do something to conserve a marine ecosystem, also to mitigate hazard if it occurs. And the exhaust of energy and natural resources, and we need to alternatives perhaps from the ocean. And we need still growth, which must be sustainable for the living ocean and coast, which is the theme of this Expo 2012. And also we need to pay some attention on the emerging technology and also the market for the future, like marine bio, minerals, and offshore plant. The offshore plant is currently the hot topic in Korea from the viewpoint of naval architecture and ocean engineers too. So there are other considerations in preparing Roadmap 2020. One is harmonization and consistency of R&D policy, because we heavily depend on governmental budget for research money. So we have kept looking what happened on the governmental level and try to keep the consistency within the framework of a marine science technology plan in the name of OK21. And also international cooperation. And yesterday I was in the expo, and I visited also USA Hall, and then the President Obama, he appeared on screen and said, ocean is combining all of us, our ocean. So that was very impressive. So we need to put more effort on the international cooperation, which we have not done so much before. So we have taken procedures for the providing Roadmap 2020. First set up vision and goal, which is most important to make it successful. And keep in mind the paradigm shift in the 21st century, and which can be characterized by the many different points, but most of all is the green code. And then we try to define the role and function of marine science technology. And after discussion, we come up with the marine science technology must be as a tool for supporting green growth through the blue revolution. Blue means the ocean. Then finally, establish strategy. And there are a lot of different strategies, but at the end come up with to be realistic and also efficient in terms of money and human resources available or available to be expected in near future. So much about background, and we move on the marine R&D in the past. So this slide shows the annual increase ratio for marine R&D. Is colored by, well, I'm sorry. So it's some strange here. So it is the annual increase ratio for marine sector. When look at here the 35% or 33% is a big increase, but sometimes it happens minus 2%. While the national the R&D has been increased largely, consistently too. So when we make it average over 8 years, then marine sector has increased by 21% per year, while national R&D only 11%. So we come up with here, although the annual increase ratio of the public R&D fund for the marine sector is high and higher than 10% than that of the national total. But the problem is each amount is only 1.2% of the total. So the government put all the money into the bio or IT other than the marine science technology. While the marine industry they contribute to our national GDP up to about 6%. So it is unbalanced, which must be dissolved in the future. So when we compare with other countries, our research money in the sector, marine sector, is only 5.8% of the United States of America, and 23% of Japan, only 1/3 of China. So we need money, simply. So it's more detailed statistics what happened over 8 years for different sectors like infra. Infra means the building up ocean observing satellite, icebreaker ships, and Arctic and Antarctic bases. So it has been reached a lot of money, but recently it started to decline down to here. And here the basic ocean measurement and energy, bio, environment, international. So when we sum up over 8 years, the infra and measurement have this portion of 24. When we sum up two items, that it come up about half of the total money. And while for international, we paid only 1%. So that is the area where we have more attention and pay more money and cooperation in the future. So there are a lot of achievements, and make it short, I mentioned only two slides. One is through the MT plan, Marine Technology Plan, strengths R&D capability through the providing its fundamental infrastructure like observation base and the ships and equipment and so on. For example, when you look at academic publications, it was only 156 good papers for good journal in year of 2005 has been almost 10 times 1,522 in 5 years. So when the government put money to professors, then they try to publish paper. No, that's no out of question. Yeah? And also technology transfer, the cases almost the same, 6. But when you look at the money, it was only 0.8 million US dollars. And 2 years ago, it was almost double, 20 times 16 million US dollars. So there are many, many examples, but due to time limit, I'll try to show you only some typical, which is visible. So, for example, here the marine, the science station in the southwest sea, about 20 kilometers from the Jeju Island, and the sea observing satellite, and the testbed for lithium observing device, and different kinds of unmanned underwater vehicles, and hydrogen from the microbe, and the icebreaker ship, Araon. Araon is pure Korean word, which means they all around the oceans. So, and here the testbed nearby from this site, well, it's very famous for strong current. The maximum current may be about 14 notch. But at this site, the maximum speed will be about 10 or 12. And it is not the real one, just the impression for the exploiting system for ocean resources, for example, manganese nodal and so on. And here underwater communication system, which is very, very successful, and is very close to the realization in practice, and also bioadhesive and so on. And if you have more information, then you may visit the YEOSU Expo. I was yesterday all day long in the Expo, and I found their show much more understandable than my explanation here. So when the government put money, then they necessarily evaluate what you have done. So it's a result, very poor result so far. So it is the technological competitiveness in terms of percent level and the gap in years. So in short, there is some relatively high in harbor, transportation, marine resources study, while it's poor or low in polar region study, marine environmental study, and so on. So there the air sector where we put more effort. So region and lessons learned over 8 years is that there are too many good ideas and programs. So the result is that inefficiency and poor performance. So nowadays we talk about vision. And the ocean research is a typical example for this vision. But still, we researchers, I guess it is only in Korea, it is not effective for you. It's something they would like to do individually, not in a group. That's the reason why the efficiency is not so high as expected. So it is the statistics, the brown one, oh, I'm sorry. The brown one is total budget in million US dollars, and the blue one is the number of projects. So the bottom, in green color, is the average budget for each project. So it's in the range of about $1 million. So it is relatively small. So it is too small to bring up big progress or big success. Then second lessons learned is that low public interest in and weak support for marine science technology. So we are connected to China on the land. So the China has affected our history and culture so strongly. So the ocean culture and history is relatively not so active in our Korean history. So perhaps the reason why is that our ocean research is maybe too difficult, too complex. So even myself cannot understand sometimes what they are doing. So, and also it takes a long time to bring out output. So, and also in the other field, there are so-called star researchers who tell story to the public. But in our area, there's some candidate for that, but then maybe not enough for public. So, and the second one is heavily depend on government, no industrial the interest. That's the reason for this low public interest, maybe. And also, even the situation is so that we try to make some the public relations, but our researchers, they would like to concentrate on their own research, and they have no interest in public relationship. So from normal people say that, oh yeah, they consuming money, but what they are doing is for their own play. No direct effect on our everyday life. Then maybe the reason why for this low interest, public interest. So we set up new directions. So the combined integrated vision, goal, budget, and also the operating strategy. And the ocean is so diverse, and research also so diverse. So then we need some the individual such a strategy for each project. And more attention on new technology. Nobody knows what happened in the near future. And third one, there are two good ideas, two good proposals, but the money is limited, so we need some priority. So the problem is the stakeholder can understand it or not. That's another problem. Anyway, we need to set up the priority. So we come up the main theme, roadmap 2020. I have only 10 minutes. Okay. So the vision of this roadmap 2020 is advanced country in the field of marine science technology. So we realized the blue revolution in order to make green growth. So there are four big issues: green growth, and response to climate change is a global issue on which we are sharing opinion with you together, and information network on this peninsula, and enhance living quality. So I skipped the detailed explanation because all these four issues is clear, understandable. So the problem is money. This morning I met my good friend Tamaki, and he congratulated me. You have 3.6 trillion US dollars for coming 8 years. So no, it's not US dollars. It's Korean won. He said, so this morning I got this booklet and read, yeah, it's in dollars. Perhaps that's what I wish it is in dollars. But unfortunately, in fact, it's not in dollars, but in Korean won. So when I prepared this manuscript, I calculate 1,000 won for $1 US. So it's very simple. Trillion get down to billion, and billion get down to million. Yeah. So after receiving too many good proposals, we try to cut down, select the 13 areas with 8 BRUSA is a big project, relatively, and 50 innovative projects. And this decision is made based on the preliminary feasibility study and in compliance with the division strategy of the roadmap. If it go along the same way or not, then lastly, financial feasibility. So I show you a short what is going on. This is a complex ocean energy plant. So for example, we may construct such a big the floating complex plant for generating energy through solar, ocean waves, current, wind, and so on. And also here the biofuel. The next one, the extraction of seawater dissolved minerals, and that is very close to realization because you know the fuel cell is made of lithium, and in the ocean a lot of amount of lithium dissolved. And new materials from the oceans. So I recommend strongly to visit the Marine Industry Pavilion. And a man, he explained wonderfully what these things going on. And next generation eco ships, where Dr. Ban, he is a leader in doing research in this area. And Korea has a strong in shipbuilding, you know, they create the first #1 shipbuilding country in the world, and also offshore structures too. Then next one is contingency plan for coastline disaster. So predict the climate change in advance, and also prepare the contingency plan and to conserve our nature, and also when accident happen, then we implement the contingency plan to mitigate this hazard. And reliable forecasting model for global oceans. So when we try to do something concerning with the ocean, the basis material is the forecasting model for the ocean. And also it's a very difficult, complex dynamic model. So we try to prepare the forecasting model, which is reliable, so-called within the 80% accuracy. So integrated network for ocean observation over the Korean Peninsula, naturally getting data from the abroad too. Then number 8 is conservation and management of marine bioresources. So all of the things is not my own. So I try to explain a little bit about what I'm doing recently. So we're talking about the CO2 gas emission and greenhouse gas. So all come from the hydrocarbon, but still we heavily depend on the hydrocarbon. And according to IEEE Energy Outlook 2030, we still depend on hydrocarbon over 60%. The one good thing is recently, the oil and gas are found not on the land, but from the offshore, so-called ultra-deep water, which means deeper than 1,500. And this morning I talked with President Botman and Carroll. They come from the Gulf of Mexico. There the ultra-deep water means that 1,500 meter is exploration and exploitation too. Then the other thing is not much oil from the sea as before, but some more gas. So the lot of new problems are coming up. So this slide shows that exploration up to 3,000 and exploitation up to 2,400 meters. That's what happened in real ocean. So one good thing is recently, no more oil as before, but more gas. So the problem is that we have to make the volume smaller. So through the liquefaction, then the volume becomes 1/600. So that's called LNG. So that's the LNG transportation route of the world. And it's the LNG most type and membrane type. You are very familiar with it. So new thing is related with natural gas. So-called LNG FPSO. For example, it's the impression, not real one, but close to real one. So when you visit the film pavilion of Expo, on the second floor, there is one model which you tell what happened, what the process is. So it is so-called LNG FPSO, and it's LNG seal. When the FPSO produces gas from the bottom of the sea, then it liquefy by get down the temperature minus 163 Celsius. So then with this cold condition, the LNG transport to the side-by mode, the LNG sea. Another example is LNG FSRU. FSRU stands for Floating Storage Regasification Unit. So for example, here is a FSRU, is again LNG seal. So the so-called, everybody needs natural gas for their home appliance, but nobody wants such a storage tank in my backyard. So another alternative solution is that on the floating type FSRU here, and receive the LNGC from LNG from the LNGC through, then regasify, then supply the houses on land. With this new natural gas related structures, there are a lot of problems. For example, two-body interacted motions on the sea, and mooring and tender, and also the off-roading. Off-roading is the main theme. Hard issue, how to transfer this minus 163 LNG to another ship on the ocean, and safety, thrashing. You may know what is thrashing. So it is experimental, it's taken the snapshot during experiment. When you look here, corner tank, the LNG is heated tank, and which may lead structural damage. And once it happens, then you may imagine the disaster. So, thank you. So what I'm doing now is such an experiment at my laboratory back at my Seoul National University. It's a very simple experiment what happened in two-body intuition, including thrashing. So for example, here the FSRU LNGC, once again please. So waves come from the left side, propagating the right side. Then when waves comes, then they start the freedom motion. So that's enough. You may understand what happened here. Okay. So this is the experimental data. So I have no intention to get into the explanation, but just to show you what happened here. So you have impression that the relative motion is quite fluctuating depending on the frequency, and strongly depend on the natural frequency of the body, which depends again on the filling ratio of the liquid in the cargo tank. So anyway, it's very, very complex problem. So in order to make operation safe, we have to investigate what happened in reality. So one of our main hot issue in Korea is how to design topside and also subsea equipment. So as I mentioned at the beginning, due to time limit, I may skip it because he's not more here. The President Kang, he mentioned about YEOSU. So the YEOSU stands for Korea Institute of Ocean Science Technology. The code, the name will disappear, and they get new name, YEOSU. Any questions?
Thank you. Thank you, Professor Choi. Yeah, is there any questions and comments for his presentations? We have maybe 5 minutes for exchanging the question and answers.
If you wanna to save time, then after this session, you come to me close personally.
Okay. Yeah. Could you please repeat? Please introduce yourself firstly. Yes.
Hi, I'm Nasser. I'm from the Australian Center for Field Robotics, a PhD student. I was just wondering, I didn't see a lot of focus on deep sea exploration.
You know that about 40% of ships navigating all over the world are made in Korean shipyards. Yeah? And also the FSO drill ship and the LNG FSO is the first time in the history is under construction by a Korean shipyard. So we have no oil field by ourselves, but the ships and the platform are mostly constructed in Korea.
Thank you. Is there any question or comment?
So if not, then I would like to thank you for your time. And I wish you not only academic works, but also you have all the time to go around the coastline around here. It's very, very beautiful. And also seafood is wonderful and very cheap. So enjoy our stay. Thank you for your attention.
Thank you, Professor Choi.